Here we go. So now we get to the trig functions. We can define them in terms of the side lengths. Okay, let's do that. So sine of theta, okay, that's the length of the opposite side divided by the length of the hypotenuse. Okay, that's what that is by definition. Cosine of theta is the length of the adjacent side divided by the length of the hypotenuse. You know, that's what this is indicating. Tangent of theta is the length of the opposite side divided by the length of the adjacent side. So again, I'm assuming theta is here. You could have theta up here, but then, you know, these two notations would interchange. But that's what the trig functions are. So that's what the trig functions are. Now, what we do also is we like to remember. I know this is a lot to remember, although since you can have the notes in front of you when you take the test and final and all that, you may not need this as much, but SOHCAHTOA is a way to remember these definitions. You know, S stands for sine, O stands for opposite, H stands for the hypotenuse. When I say opposite and hypotenuse, I mean the length of those sides. C is cosine, A is the length of the adjacent side, and T is tangent. So you could remember them that way. Now, of course, those are not the only trig functions, though. There's actually 3 others, and this is how we define those. We have what's called secant of theta. We have cosecant of theta. And we have cotangent of theta. That's what we have there. See how they're defined. Now, I know this is also a lot to remember. I mean, the way I remember it, I'm going to show you shortly. It's actually based on identities. But these are 3 other trig functions. Okay? Yeah.
So basically for these, the secant, cosecant, and the cotangent, is it basically like 1 over sine and then 1 over cosine and then 1 over tangent?
I'm going to get to that, yeah.
Okay.
I mean, those aren't the definitions, but that's actually how I like to remember it personally. I mean, you could remember the definitions if you want to, but the other way, as you're saying, is this, the reciprocal identities they're called. So.
Oh, I see.
Yeah. Okay.
Okay. Thank you.
Okay. You're welcome. I did again. You do have the note, everyone. You do have the notes in email. I emailed it to you, everyone. Just letting you know as well. But but these are just identities you can actually prove easily from the definitions. Just takes a little bit of algebra, not much though. But cosecant of theta is 1 over sine of theta. Secant is 1 over cosine of theta. Cotangent is 1 over tangent of theta. And from there, we can also get tangent is sine over cosine of theta. Cotangent then is cosine over sine of theta. So we have these identities. Okay. And also, so far, I've been saying that theta is in degrees. If theta is measured in radians, the definitions are exactly the same. The definitions would be exactly the same. I think the only real difference, though, would be that, where is it? 90 degrees would be pi over 2. And 0 degrees would just be 0 if we were working in radians. The definitions, though, would be exactly the same. All right. When you do work with these, the 1 over stuff, you know, this is a good how do I say it? Identity to know. When you have 1 over something, like 1 over a fraction, you're taking the reciprocal of it, which means you're inverting it. That's what this is telling us. 1 over a fraction means you're inverting it, you're turning it upside down. Also, this is really just from how you divide fractions. 1 fraction divided by another turns out to be this. Essentially here, the c's, these denominators, they cancel, and you're left with a and b. That's what happens here. That's what happens here. Okay? All right. That's reciprocal identities. In fact, from there, we can actually get the following, not really identities, but it's just something I wanted to present. From using this here, right? Keep in mind A, B, and C are not 0, which makes sense because you never divide by 0. You can actually get these here, identities. So for instance, since cosecant of theta is 1 over sine of theta, essentially you're just going to interchange cosecant and sine. You get sine of theta is 1 over cosecant of theta. Secant of theta, 1 over cosine of theta. From here, you get cosine of theta is 1 over secant of theta, and so on. And actually, I forgot to say this. You can actually get all the trig functions in terms of sine and cosine. Hold on. So once you know the values of sine of theta and cosine of theta, you can easily get all the other trig functions using these identities. Now, how do you get from here to here? I did the proof here. Again, it's really just cross multiplying. That's all it is. So there's not much to it, though. Like, for instance, I did the first one. If you have cosecant of theta, right? Cosecant of theta, that's the same thing as cosecant of theta divided by 1. Okay? So really, from here, this identity is really the same as this one. Okay, what does this mean? Well, if you were to cross multiply like you could with regular fractions, you would end up with this. Right? When you have two fractions equal, this is equivalent to saying that you can cross multiply and the equality is still preserved. So this is true. And what does this tell us? Well, if you divide by sine of theta, cosecant of theta, you would get this. That's all. I figured it wouldn't hurt to present this, so it just saves us a little time. And the other equations there, cosine 1 over secant, tangent 1 over cotangent, you could prove those in a similar way. Pretty easy. It's actually very easy. Thank goodness. So, okay. Are there any questions about that? Okay. So, and also another famous theorem that you're going to have that's good to know is Pythagorean's theorem. That's a very, very nice theorem about right triangles. What's nice about that theorem is if you actually know any two of the side lengths, you automatically know the length of you can easily get the length of the third side. If A and B are the lengths of the legs of the right triangle, and C is the length of the hypotenuse, which is, again, the side opposite the 90-degree angle, then A squared plus B squared has to be C squared. Pythagoras' theorem. Oh, yeah. But that's a good theorem also that will come in handy. Good to know. Okay, so with these trig functions, okay, we can actually use them as so. Let's say, so from here, let's find the length. So let's say we have this right triangle, okay? As you can see, theta is an angle between 0 and 90 degrees, okay? What we're going to do is get the length of the third side here, and from there we can get the length of all the trig functions. We can get all the trig functions at theta. We don't know what theta is, but that's okay. We're not going to try and find it. I'm not sure if I don't think we have enough information to figure it out anyway. All right, so How would you get the length of the hypotenuse? That's just Pythagorean's theorem, right? You know, we have 3a squared plus b squared is c squared. In this case, a is 3, b is 4. So 3 squared plus 4 squared, we have a c squared. Which is actually the same as saying c squared is 9 plus 16. So c squared is 25, right? And of course, that tells us that c is the square root of 25, which is 5. So that's what we get here. So we get c, the square is 5. Now, once we have that third side, we can get all the trig functions of theta. And this is what we do. I put the definition here. So sine of theta is the length of the opposite over the length of the hypotenuse, right? Well, the opposite side has length 3 here. Hypotenuse has length 5. So sine of theta is 3 over 5. For cosine, the length of the adjacent side is 4. So for cosine of theta, we have 4 over 5. And tangent of theta is 3 over 4. Tangent, we actually don't need the hypotenuse. But and then you get the others. So cosecant is 1 over sine. 1 over sine, right? Sine is 3/5. That's 1 over 3/5. But 1 over means you flip it, so you get 5/3. Secant of theta is 1 over cosine of theta. Cosine we said is 4/5. 1 over that is 5/4. Finally, cotangent of theta, right? That's 1 over tangent. But tangent's 3/4. That's 1 over 3/4, which is 4/3. 1 over, again, that just means you flip it. You invert it. That's all it's saying. You have any questions about this one? Because we're going to do some others also. Okay. All right, the next one's a little bit different. Here, what I'm telling you is that cosine of theta is a third. Using that, we're going to find all the other trig functions, but we're not going to try and find theta. All that we know about theta is that theta is an angle between 0 and 90 degrees. Okay, with this, how could we possibly get all the other trig functions? I mean, theoretically, all we would is sine of theta, then we can get all the others. But let's just do this.